All right, Chem 20s, let's finish off this stoichiometry unit with the last section of Stoic called Solution Stoichiometry, which is our Chapter 5 and even a tie into Chapter 6 that we could extend. Again, lots of examples throughout the chapter that you should be paying attention to if you're struggling with your understanding after I've gone through these couple of examples, but I would assume and I would hope that the process is starting to go pretty well for us, that you're seeing how repetitive this is, that it's really just the units that have to be converted that is any of the issues that we might have with this. So now we're dealing with the solutions. In gravimetric Stoic, we learned that, and we remembered that, the conversion between mass and moles was molar mass. In gases, we had a bunch of ways to get there. It could have been the molar volumes, or it could have been the universal gas constant. In solution Stoic, while we did look at a bunch of other ways to describe concentration, the only one that carried moles through the solution was the molar concentration, or the mole per liter concentration. So, we take a look at this one. It says, calculate the volume of a 0.14 sodium chloride solution. All right, 0.14 m, or square brackets, both mean moles per liter. And we want that to react completely with 20 mils of a 0.1 molar lead to nitrate solution. So we do have our limiting reagent being described as NaCl. It says, in addition to that one, in designing an experiment, how can it be made certain that all of the lead to nitrate is consumed? Okay, so as we do this, so we've got two different questions here. We'll start with the volume necessary to completely react our lead to nitrate. I apologize, I was not reading clearly. We want to completely react lead to nitrate. So that must be the limiting reagent. And we have two different starting points here. You have 0.1 moles per liter, or 20 mils. I like, just like with our gas law problems, starting with anything that has moles. And so a 0.10 mole per liter concentration of lead to nitrate probably is the best starting point here, because it allows us to put moles into the correct spot in our factor label method. Now we just need to cancel out those liters because the volumes are likely to be different. And so I'll put my 20 mil volume in the numerator. Liters will go, and you see that metric system survival here of millimoles. Don't worry about it. It's going to take care of itself in just a moment. We do need to get rid of lead nitrate here, though, and get to our information on NaCl. And you can see in this particular problem that it is 2 parts, or 2 moles NaCl for every 1 part lead nitrate, and that removes the lead nitrate from our problem. And now you have millimoles of NaCl. So we have that mole quantity, which is great, but we are trying to turn this into a volume, so the moles should be canceled. And lo and behold, we have moles per liter as the concentration of this other solution. And so moles should go in the denominator, liters up top, and it is 0.14 moles per 1 liter, and moles now disappears, and so you have milliliters of volume. All right, this is probably a good way to keep it because you have milliliters every other solution, so this is probably comparable. And so run this through your calculator, and you get 28.571 milliliters. 3 digits, 2 digits, 2 digits. This is a 2-digit answer. 28, and the 5 rounds you up. So therefore, 29 milliliters. Now that is the answer to calculating the volume of how much sodium chloride should be used. At this point here, if I want to know how much should I use to make sure it's completely consumed, please remember the 10% rule. And so I would multiply this by 1.10, and sorry, I've run myself out of room here, but that would be a 32 ml volume that I would likely use if I had to run this in a lab. Remember, stoichiometry always predicts for us a minimum amount based upon the minimum balancing of our chemical equation. So 29 mils would effectively consume all of the lead nitrate, but it would take an awfully long time to get it done. So we want a little bit extra, but not wasteful. So we go 10% excess and make sure that we add a little bit more so it consumes the limiting reagent in a quicker fashion. All right, so 29 mils for question 1, and I believe the rounded answer would be 32 mils for the second part of the question. Down here we have a acid-base neutralization problem that we're looking at. Okay, 14.5 mils of a 0.147 base solution reacts completely with 10 mils of hydrochloric acid, a strong acid. What must be the concentration of the acid, and what is the pH? So we can figure out the concentration much like we worked through this last problem. Okay, I would probably start with the concentration of my sodium hydroxide. That's one of my givens, and it has moles in the numerator. So 0.147 moles per liter of my NaOH. You can see the differing volumes here, so I will have to limit this to moles, so I should cancel out my volume here. And so 14.5 mils of sodium hydroxide. The liters now go, and I have millimoles of sodium hydroxide. Now it's safe to do my mole ratio. NaOH I want to get rid of. HCl I want to find. And you can see from our chemical equation here that it is a 1-to-1 ratio. But that's okay. While it doesn't change the numbers, it does get rid of NaOH and now turns us into a millimole quantity of HCl. Fantastic. We just need to turn this into a concentration. So we have moles. We just need to put the volume of 10 mils in the denominator. And so the milli part of this will disappear. And now you have moles per liter of HCl. Okay, so it is safe to use the metric prefixes in this strategy. If you don't like that, change it to standard values. I know you guys can work the metric system that well. And so when you calculate this one, we end up with 0.213 moles per liter of our HCl. Now the second question, I realize now that I can't ask you this because we didn't get into some of the rules about strong and weak acids. We do realize, or maybe we do remember, because we talked about it briefly, that strong acids do ionize 100%. So the hydronium ion concentration of any strong acid will be the same as the concentration of the acid. So we could use this in our negative log formula to figure out the pH. So I will show it to you just for fun. Okay, so where the concentration of a strong acid like HCl, because it ionizes 100%, would be equal to the concentration of any hydronium. So therefore, the pH of that acid solution would be negative log of your hydronium. But in this case, since we don't see it in the equation, it would be negative log of your strong acid, which is HCl, which we just found out to be 0.213. All right, so for that one then, the pH, when we calculate this one out, will work out to 0.671. Mistake right there. 671 as we calculate it. But I can't ask you this part here. That's going a little bit beyond because we did eliminate all of our discussions about strong and weak acids and where you would get this in chapter 6. So you can ignore that, but for those that wanted to see the solution and geek out a little bit, appreciate it, enjoy it, and there you go. You'll see on the next page that there are some extra stoichiometry examples. If you just want to try these ones out, go nuts. All right, you'll notice that answers are provided for most of them. Give them a shot. If you're having troubles with any particular ones, I would expect you guys to be checking into our tutorial session on Friday. and making sure that you're asking your questions. That brings us to the end here. So 300 to 303 in the textbook is the last section on 7.4. Make sure that you're trying questions on 302 and 303 to finish off this solutions idea. Lab 7C is going to be submitted to Dropbox. Make sure you're doing that. You may wish to try Lab 7D as well and check that one on D2L. And then finally, the Chapter 7 review is on page 308 to 311. I would encourage you guys to do this in a random order just to practice your reading comprehension skills and test yourself on these things a little bit out of order to see if you can, number one, identify what's there and figure out your best strategy through it. Again, do your best with this. Practice, practice, practice. There are extra worksheets on D2L if you're looking for more, but this is your absolute fundamental skill in Chemistry 20, and we use this a ton in Chemistry 30. So make sure that you are proficient with this. Ask for help if you need it. I will be there for you on Friday for anybody that is struggling with this. We will also have another tutorial the following Friday, which is still in advance of your quiz. Okay? Good luck with all of this. I hope the videos are helpful to you. And yeah, do your best with it and make sure you have a grasp of Stoic.